Now we are ready to dig into question 3. So in question 3, you are once again given the header here called present value of annuity. If you were not given this one, you could still see that it was an annuity. So let's just read the question. Vega wants to save up money for a car. She will set aside 20,000 kroner every year in each of the next 5 years. And she gets an annual return of 8% on this saving. So you can see here that when you have a limited time period of 5 years and you have a constant payment, you are looking at an annuity. The interest rate has now changed to 8%, and we need to find the present value and the value after 5 years, that is a future value. So let's just find the present value of the annuity first and see how we can quickly also find the future value. So let's jump into our calculation sheet. We know that the interest rate is now 8%. Number of periods. So that's our T. That is now 5%. Or sorry, 5 years. And the last thing we need to insert is our cash flow. And we can say that is from T equals 1 to T equals 5, because we start the payment in 1 year, and that equals 20,000 kroner. So now we have all the input we need to find our annuity. If we go to the formula sheet, you can see here that we are looking for the present value of an annuity. It is not an annuity due simply because it starts in 1 year. It says in the assignment that it is end of year. So if she saves up end of year, that means that we have 1 year until the first payment. So let's just get the formula copied in. So we can use it for calculation. I'll just put it over here like this. So when you have a formula like this, it is a little bit more complicated to actually type this into Excel. So let's just have a look at how it's done. So we are finding the present value here at time 0. So why do I say that this is a little bit complicated? That is because you need to get all the parentheses correct, and furthermore you actually have to add, normally with a lot of these formulas, a few more parentheses. So I always try to add enough. You can always add as many as you want, as long as they are correct. But let's see how it's done. So the annuity present value here, that is the cash flow, and that's the first cash flow in the annuity, multiplied by, I start a parenthesis, then I start another one just to show that I want this one calculated in here, 1 divided by the interest rate, parenthesis stop, minus, then I start for the next fraction here, 1 divided by, and then I have a parenthesis for the bottom, that is the rate, that's the R down here, multiplied by 1 plus the rate into the power of T. Then I'm done. I just have to close 1, 2, and 3 parentheses. So you can see here that my solution to this question is 79,854. So that is the present value at time 0. I will just save the conclusion for just a minute. So why is it annoying to insert all this in the exam? It's annoying because often you mix up the parentheses. So is there alternative ways that we can do this? Yes, there are. We will see them in just a minute. First, I will just answer what is the future value here at times 5. You can see that is the second element of the question. So we have found the present value. We simply use the formula for an annuity. And now we have to find the future value. There are more ways to do that. We could go in and say, all right, we have a formula here called annuity future value. But what you can do, and that's a shortcut, is just to say this value must be the same but just in present value. So we can take this one and discount it forward or compound it with 5 years. And then you would see this is the value that you have after year 5. This is 2 different ways to do it. You can say you find the present value of the annuity and you simply take that value and compound it forward. Alternatively, you could have used the formula here for a future value of an annuity. To this assignment here, I want to show you one extra thing. And that's the example I've just prepared in the next sheet. So what I actually want to show you here is that there are more ways to finding the right solution. So this is the question we just did. You can see here we have the 5 cash flows of 20,000 each. You can see here I have done a row called present value at time 0. In this one I have taken all the cash flows and discounted them back with the specific number of periods. You can see it goes again down here. I have logged the rate because that applies for all the periods. When I then take the sum here of all the individual cash flows, you can see I hit 79,854, and that was exactly the question we found here. Furthermore, I could do the same for future values, so you can see here that this is the 20,000 compounded forward with 1, 2, 3, 4 years. You can see that I have used the T minus I that comes from our formula. Let me just show you. So this one here, the future value of a cash flow stream, you can see that 5 and 1, that gives me 4 periods, and that is what I have used here. So this is another way to calculate this assignment where I do not use the annuity formula, but I actually set it up with a timeline in Excel. This timeline is extremely helpful to do if you have more complicated assignments where you maybe have to combine an annuity with a perpetuity and you have to find that value at different times in the future. Down here you can see this is actually what we just did before. You can see this was the formula we applied, formula 43A. And the formula down here, that's the alternative I talked about. That's 44A. That gives me the same result as up here. The final option you have to calculate the sum is that Excel has some built-in formulas. The built-in formulas in Excel are good to check if you have found the right result, but in a solution for an exam, it's not enough just to show this one. But it's a good way to check, did I actually find the right result? So what Excel needs as input here is the rate, number of periods, the payment, and it needs to know if we have an annuity or an annuity due. So if I type in 0 here, it means it is an annuity. If I type in 1, it's an annuity due. The reason why I have a minus before the payment is because Excel understands this as if the payment is negative, it's a saving, and it will give me a positive present value. If I delete the negative here, it means that it's a payment and I will have a negative present value. So that's why I have the small minus here. And we also have a formula for the future value that is called FV, and you can see it works in the same way. So I just wanted to show you this one because I think this is extremely important for the exam, that if you are in doubt, you can always set up a timeline. Just make sure you make room for period 0 if you have an annuity due or a perpetuity due. Now we are ready to write the conclusion. So the present value of the annuity is 79,854.2. The future value of the annuity is 117,332.02 kroner. So that is the 2 conclusions. Now we are ready to jump into the next assignment, which is, or the next question, which is question 4. where we have to find the present value of a perpetuity. Why do we know that we have to find a perpetuity now? Let's read the question. So Vega's parents want to support Vega financially, and they have set up an automatic annual money transfer of 2,500 kroner to Vega. This support will continue in all future years. Here you have it, right? So if you have a cash flow that is never ending or continues forever, you are to calculate with a perpetuity. The relevant discount rate is 5%. So let's just get the information into the sheet. We have the interest rate, that was now 5%, and we had the cash flow, and that is perpetuity cash flow. So I can write cash flow in perpetuity like that, and that was 2,500. That is actually all the information we need to find the present value at time 0. You can see here we have no growth. So if we look in the formula collection here, you could also for this one have gone through all the different questions here, and that's a good way to do the first times you calculate assignments like this. So this one would quickly be, okay, we need to find the present value. So we asked, what is the value today? What are the characteristics? It continues forever, so we are looking at a perpetuity. Do we have any growth? No, that is not stated in the question. That means that G is 0, or we do not have to include G. And the last one here is, when does the period start? It starts in 1 year. If it's not stated when the period starts in a question, always assume that it starts in 1 year, because that is the most normal. So let's go back here, and we need to find this value. So in the formula sheet, if we go back here, we have two values or two formulas for a perpetuity, one with growth and one without growth. In this one we had no growth, so let's just copy in our formula here, because that's the one we want to use. And I will once again just put it on the side here so you can see it. And if you are using Word, Math or another math typer, you can insert it as well. And the value, the present value here, is simply the cash flow divided by the interest rate. That gives me a value of 50,000 today. That means that our present value is 50,000 exactly. So that was a quick question on perpetuity. Now we will jump into a slightly more difficult question.